right, let's go and get started by taking a look at page 373, the review, numbers 15 through 19. Page 373, the review, numbers 15 through 19. We have a quiz coming up in just a few minutes over probability. But before we do, I want to take some time to go over the homework and review some things with you before we get to that point. So let's go ahead and take a look at the homework. One of the shortest assignments you'll get all year. Just numbers 15 through 19 at the bottom of page 373, Scott. Ah, there it is. Good. All right. Now, the first few even should have taken like, I don't know, 15 seconds total to do all three of these. How would we simplify number 15, Joshua?
25 u cubed w to the fourth.
Good. 25 u cubed w to the fourth. Number 16, Lana.
6a squared bc cubed.
Good. 6a squared bc cubed. And number 17, Scott.
8n cubed z.
Good. 8n cubed z is correct. Number 18. To express each probability as a reduced fraction, or the way I put it, as a ratio, which is the way we'll do it typically in this class anyway. James has 3 pens and 2 pencils in his pocket. What is the probability of randomly pulling out a pencil? Lana?
2 to 5.
2 to 5. There are 5 utensils in the pocket. 2 of them are pencils. 2 to 5 probability. How many had that answer? Uh-oh. Did you do 2 to 3?
No.
What did you have?
1 to 6.
Okay. Number 19. A festival game involves throwing a ball onto a spinning platform with 1 white cup for a grand prize, 10 blue cups for a small prize, and 14 red cups for no prize. What is the probability of getting a prize? Joshua? 11 to 25. So here's the idea. Remember, we want to start by finding all possible outcomes. How many possible cups could, assuming the ball lands in a cup? I guess we should say this, well, what if it doesn't land in a cup at all? That wasn't a possibility. So assuming it lands in a cup at all, how many cups were on the spinning wheel, class? 25 different cups were there. 14 of them, you got nothing. 10 of them, you get a little something, and 1 of them, you get something really nice. But how many cups do you actually win at least something? 11. The 10 with small prize plus the 1 with grand prize. So there are 11 cups you can actually win something. Out of a total of 25, it's an 11 to 25 probability. By the way, what do we call the 25, the total number available, class? It's the sample size or the sample space, right? And the desired outcome here would be, I want a prize. I want at least something from this game. Now, if you wanted the grand prize, what's the probability? 1 to 25. Now, again, I will say this isn't a true probability problem in that it doesn't account for athletic prowess. Some people might just be better at tossing a little ball than other people, right? Some people could do it, some people can't. So if you're like, I can't toss a ball to begin with, I'm not even going to get it in a cup. Okay, then you already start with a lower probability, okay? But if we're assuming all things being equal and we know the ball's going to get in one of them, I don't know, maybe there's a little chute or something that you drop it down so it can't possibly miss the wheel. I don't know. But anyway, 11 to 25 is what we're looking for there. Questions on that? By the way, what do we call the probability of something not happening? The complement. And remember, if I wanted, for instance, the probability of a prize, how would I notate probability of a prize? Lana? This isn't asked there. You're not going to find it in your book. How do I notate probability of a prize? That probability notation we talked about. Josh? Right, P parentheses prize, right? And of course, if I had the probability of no prize at all, then I would put a little C for the complement of not any prizes. So the complementary probability, put a little C there, it just means the probability of something not happening. Now, in our last lesson, I emphasized to you that you can sometimes use the probability of events not occurring to find the probability of at least one thing happening to pass. We said those will be complements. Nothing and at least one have to be complementary to each other. So we used that fact. Of course, we know that the total of all probabilities in a situation class have to add up to 1 or 100%. The probability that something will definitely occur, 100% or 1. The probability something cannot possibly occur, 0 or 0%. And of course, we know all probabilities have to lie between those values, don't they? You couldn't have probabilities that add up to more than 1. You couldn't have a probability greater than 1 or less than 0, a negative probability, I suppose. We also said if you wanted to know how many possibilities exist in a certain situation, and we had maybe a few of these you could choose from, and you had a few of those you could choose from, a few of the other. We said you could make a really detailed list of everything, Scott. We didn't like that idea. Then we said we could make little tree diagrams. Well, if you pick one of these, and then what if you pick that, then you might have to pick one of these. And we said we don't like tree diagrams either. So what was the basic essence of the counting principle that we were using?
Multiplication.
Yeah, just multiply.
Yeah.
Right? So, if you got 3 of these, you got to pick one of these 3, you got to pick one of these 5, and one of these 6. Well, the probability is that if you were to take any one combination of them, that's one combination out of 180 choices. 90 choices. 3, 5, and 6. You'd multiply 3 times 5 times 6 to get 90. Well, there's 90 total things there, 90 ways you could put it together. So if you pick it this way, that's one of 90 different ways to pick. Okay, let's practice with those as we take a look at our PowerPoint here. Let's try that again. Let's try doing that. All right, and if you would, go ahead and read this problem for us, Scott.
A pet store sells dog food in 3 brands, A, B, and C. All 3 brands are available in large and small bags and come in the following flavors: chicken, beef, and turkey. How many choices are available?
At your seats, how many different choices are there in picking the dog food? How many different choices are there as far as dog food? Do this using the counting principle. Don't use the whole tree diagram thing or whatever. All right, what did you get here, Lana?
9.
9? All right, so we've got 3 different brands we could choose from. And in every brand, there's 2 different sizes we could choose from. And then for every size, there's also 3 flavors we could choose from.
Oh, the 2.
So we have to make a choice of brand, we have to make a choice of size, and we have to make a choice of the meat that is the base of the food. So, how many different choices should we have had? 18 different choices. How many had 18 choices? You had 18 choices. Now we do. Okay, does it make sense though? All right, so you're looking at each choice has to be accounted for. Let's take a look at another one. Lana, this is your problem. Go ahead and read it for us.
Anna is trying to choose a car to buy. She isn't sure whether she wants a full-size sedan, small sedan,
Coupe, it means it only has 2 front doors, no back doors to get to the back seat.
or hatchback. She isn't sure which of 4 leading manufacturers she will choose. She also can't decide between red, silver, or blue. How many choices does she have?
I love those Patriot colors. All right, so anyway, so what are the chances then? We could say that you get a blue Honda hatchback, okay? So that's, well, at your seats, how many choices does she have of a vehicle? If she's narrowed it down to, I want one of these 4 body types, I want one of these 4 manufacturers, which are not named, because none of them are sponsoring these YouTube videos, and we also have 3 colors there. And nobody really wants white because white shows too much dirt, but silver doesn't show dirt as bad. Plus Patriot colors. All right, Lana, what you got here?
48.
Good. How many have 48 different options available? So she's going to choose 4 different body styles, 4 different manufacturers, and 3 different colors. Comes to 48 different choices of car. That make sense? Can't count. All right. Questions on this? Questions on this? All right, next one is Scott's problem. Scott, read this for us, even though you didn't win the airhead last time.
The bag has 4 airheads in these flavors: mystery, blue, raspberry, cherry, and watermelon. When Scott picks one out, replaces it, and draws a second time, how many different ways could he draw out an airhead? What are the chances he does not pick the mystery flavor either time?
Just do the first part of the problem. How many different ways could he draw out an airhead? For instance, if he drew cherry and then he drew watermelon, that would be different than drawing out, say, mystery and then watermelon. So how many different ways could he draw out the airheads? right, Scott. You got it? What you got? 16. Because the first time he draws, there's 4 flavors. Now, assuming he puts his first draw back in, shake them up a little bit, there's still 4 flavors he could draw from. So that's 16 different ways. Now again, that assumes that drawing cherry then watermelon is not the same as drawing watermelon then drawing cherry. Does that make sense? That's different ways, but 16 different ways he could draw them out. Each time, there's 4 different ways, 4 different things he could draw. Now let's take a look at the second part of the problem. What are the chances he doesn't pick the mystery flavor either time? So now we're going to change gears and think probability. On the first draw, what are the chances he does not pick mystery? 3 out of 4. Because of the 4 airheads that are in there total, if he doesn't want mystery, 3 of them aren't that. Only 1 of them is, right? Then we come to the second draw. Well, assuming he puts the first one back, whatever it was, what are the odds he doesn't get mystery on the second draw, class?
3 to 4.
3 to 4. So what are the odds he draws, looks at it, puts it back, draws again, looks at it. What are the odds he didn't draw mystery either time?
9 to 16.
9 to 16. So let me ask you, if there's a 9 to 16 chance he won't see mystery at all, what are the chances that at least one of the draws does get mystery? 7 to 16. 1 minus 9 to 16 would be 7 to 16, which means almost a 50% chance, right? 8 to 16 would be 50%. There's almost a 50% chance, just a little less, that he would see mystery. There's a little bit over 50% chance no mystery comes up. Make sense? Questions on that? All right, Josh, your problem. Read this for us.
Joshua is playing Monopoly and will roll both dice. How many different ways can he roll 2 dice?
All right, let's stop there. How many different ways can he roll 2 dice? So he shakes them up, rolls them out. How many different ways could the dice come out? At your seats. How many different ways could the dice come out? Now, obviously, we know we can only roll 1 through 12. But for instance, there's several different ways to roll a 7. Several different ways to roll an 8. So how many total ways could the dice come out? Lana?
36.
36. There are 6 different ways the first die could roll, and the second die also has 6 different ways it could roll, so there are 36 total ways dice could roll. Now again, that means that if he gets a 6 and a 2, that's different from rolling a 2 and a 6, for instance. Does that make sense? Okay, so that assumes now, he's like, but it's still an 8. Right, but it's still a different way for the dice to come out. Does that make sense? All right, so 36 different ways the dice could roll. Numbers. Let's take a look at the second part. What are the odds of rolling a 12? Joshua, you've played Monopoly or games involving dice before. The only way to roll a 12 is if you roll...
Oh, I played the junior one. I don't think you did.
Well, in general, anytime you have 2 dice in your hand, the only way you're going to get a 12 is if you
A
roll
6 and
a 6 and a 6, which means your first die has to be a 6, correct? What are the odds the first die comes out a 6?
5 out of 6.
The odds that it does come out a 6.
Oh, it does come out of 6. 1 to 6.
1 to 6. There's a 1 to 6 chance that he rolls that first die, it comes out a 6. What are the odds the next number you roll is also a 6? Because, Joshua, in order to get a 12, they both have to be 6, don't they? What's the odds the other one's a 6?
1 to 6.
So in other words, Joshua, the odds of actually rolling a 12 are
1 to 36.
1 to 36. In other words, it would take, theoretically, every 36 rolls before you'd get, statistically, another 12. Now, that's not technically true. Have you ever noticed 6s seem to come up more often than other numbers? Do you know why that is? Because everywhere there's a number, the numbers aren't printed on dice, are they? They're kind of hollowed out or scooped out. Have you noticed that? It's a little indent. Well, that means the more indents there are, the lighter that surface is. So what's the heaviest side of a die? The 1, which is always opposite the 6. So the heaviest side landing down would be the 1 landing down, which would put a 6 on top, which is why it seems like you get more 6s than anything else. But if it were not that way, and it's a very slight mass difference, very slight, okay? But technically, now, they also make things called loaded dice, where the dice have in them at the bottom of the 1, or for instance, oftentimes they'll do it on the 3 and the 4 to get the 3 and 4 to come up. They'll weight one side of the die by injecting something in when it's being cast. Okay, loaded dice are called cheating, okay, and they can lead to short lifespans in Las Vegas. Number 1, don't go to Las Vegas. Number 2, don't use loaded dice. But anyway, there's a 1 to 36 chance he rolls a 12. What about an 11? How can you roll an 11? There's only one way to do it, class.
A 5 and 6.
A 5 and 6. Now, here's the deal. Stay with me here. The first die could be either a 5 or a 6, correct? So what are the odds the first die is either 5 or 6? 2 to 6 or 1 to 3, right? Of the 6 things that could come up, a 5 or a 6 gives you 2 choices now, right? But if the first one's a 5, to get an 11, you'd have to now get a 6, and only a 6. Or if you got a 6 on the first one, you'd have to get a 5, and only a 5. So you have 2 choices of what you could get, 5 or 6 for the first die. But the second die is set based on what the first die comes out to, correct? So how many options are there for the second die? Only 1 to 6. Does that make sense? So what are the chances of rolling an 11?
1 to 18.
1 to 18. Does that make sense? Now, there's another way to look at that. Of the 36 ways to roll dice, 5, 6, and 6, 5 are 2 out of 36, or 1 to 18 ways to get it. That's another way to look at it. But that way starts to get a little bit dicey. Let's take a look at the odds of rolling doubles. What does doubles mean, Scott? The same number. Now, the first number, I didn't specify what kind of doubles, right? So the first number could be a 1, a 2, a 3, a 4, a 5, or a 6, right? Could be anything, as long as the next number exactly matches it, correct? So on the first die, it could be anything. It could be, class, a chance of...
1 to 30. Wait.
The first die could be whatever. We don't care. It could be anything. So 6 out of 6, right? Or 1. Right? The first die could be anything. We don't care. But once the first die is determined, the next die better match. If it's a 3, it can only be a 3 in order to qualify for doubles, right? It's like, well, it was close to a 3, so we're going to call that doubles anyway. We'll let you roll again. Okay, for those who play that game where you keep rolling as long as you get doubles. So what are the odds that the second die perfectly matches the first? 1 to 6. Because whatever this is, there's only one number that would match it, right? Out of 6 on that other die. So what are the odds of rolling doubles? 1 to 6. So statistically speaking, out of every 6 rolls you have, doubles should come up, statistically speaking. Now, Murphy's Law says that if you need doubles, you won't get them, okay? But, you know, and usually what happens, like, is you'll go on a drought of no doubles, and all of a sudden you're like 3 doubles in a row, and it's like, well, this is great. But statistically speaking, 1 out of 6 rolls should come out doubles. Let's take a look at the next one. The odds of rolling an 8. Whoa, how many different ways can you make an 8? 4 and 4. 6 and 2.
7 and
2 and 6.
7 and 1.
7 and 1 on dice?
No.
Oh wait, no.
In fact, that's the only way you can't get an 8, correct?
Yeah.
You roll a 2, you could still get a 6. Roll a 3, you could get a 5. Roll a 4, you get a 4. Roll a 5, you get a 3. Roll a 6, you get a 2. But if you roll a 1 on the first die, there's no way you're getting an 8, right? So on the first roll, only one number couldn't possibly ever get you an 8, correct? So what are the odds the first die can set you up to get an 8? 5 to 6. Now, once that first die is determined, you better roll a specific number the second time, correct? So if it comes out to a 3, okay, now it has to be a 5. You roll a 6, okay, now it has to be a 2. So there's 5 different numbers that could work on the first die, but the next number has to be something very specific. So the next die, the probability is only 1 to 6. So what is the probability of rolling an 8 if it were just rolling at random? 5 to 36. So which is more likely, doubles or an 8? Doubles is 1 to 6 or 6 to 36, right? Whereas an 8 is a little bit lower probability. Not coincidentally, a 7, which is a common number in certain dice games that I would not necessarily recommend. But anyway, a 7 is a fairly common number. Its probability is the same as doubles. 1 out of 6 chance of rolling a 7. What are the odds of not rolling a 4 on either die? Well, what are the odds the first die isn't a 4?
5, 6.
What's the odds the second number is not a 4?
5, 6.
So what are the odds you don't get a 4 at all when you roll?
25 to 36.
Do you notice that's more than a half probability, right? You're more than likely not going to get a 4 on one of your dice. What's the probability that at least one is a 4 then? It's not up there, but if there's a 25 to 36 chance of no 4s, then what's the chances of at least one 4?
11 to 36.
What?
11.
11 to 36. If there's a 25 to 36 chance you don't get any 4s at all, the complement of not getting 4s would be that at least one of them comes to a 4, right? So complementary probability, 1 minus 25 36 equals 11 36. Does that make sense? Let's take a look at another one. All right, and Scott, read this for us.
In a game of risk, the attacker rolls 3 red dice. A 1 is an automatic loser on any die. What are the odds the attacker will not roll a 1 on any of his dice? What are the odds that at least one of his dice will have a 1?
All right, at your seats, find the odds that no 1s come up at all for the attacker. He's rolling 3 dice. What are the odds he doesn't get a single 1, which is what he wants? He doesn't want to see 1s, okay? For the who's played Risk in here? Okay, you two know what I'm talking about then, right? Ones you can't possibly win with a 1, so you definitely don't want any 1s. How favorable are your odds that you avoid automatic losers? Let's see what we got here. Lana?
216. Well, wait.
Well, there are 216 different ways you could roll,
so
right?
3 over 216.
Ooh.
There's 1.
Well, what are the odds you don't get a 1 on the first die?
1.
No. That's odds you do get a 1. What are the odds you don't get a 1?
5.
5 to 6. What's the odds you don't get a 1 on the next die?
5.
And the odds you don't get 1 on the third die. So, what are the odds you don't come up with any 1s at all?
75? Wait. 125.
125. 125 to 216 chance you will not get any 1s. Is that what you had, Scott? Is that what you had? Yeah, not get any 1s. We don't want any 1s at all. All right, does that make sense? Okay, so then, what are the odds you will have at least 1 1? What are the odds you get at least 1 1? And for redemption, Lana, what did you get?
91 over 216.
There we go. How did you get that, Lana? Subtract it. Because the odds of nothing and the odds of at least 1 of that thing are complementary to each other. So in other words, that's better than a 1 to 3, not quite 1 to 3 chance, right? No, that's better than 1 to 3, right? It's a better than 1 to 3 chance. So every 3 times you roll the attacking dice, you're pretty much guaranteed that at least on the third roll, you're going to wind up with at least 1 1, okay? But the odds are technically better of no 1s than the odds of getting a 1. So the odds are in your favor as the attacker. Questions on this? Let's take a look at the next one. Go ahead and read this one, Joshua.
In the game of Risk, the defender rolls 2 white dice. A 6 is an automatic winner on either die. What are the odds the defender will roll a 6 on at least one of his dice?
All right. Now, it says at least 1. How do you find odds of at least?
Subtract.
Find the odds of
No.
not getting anything,
yeah.
and then take the complement. So at your seats, do the whole process here. Find the odds that the defender will roll at least a single 6 when the time comes. As a defender, you really want a 6. Make the other guy lose. What are the odds that you get at least 1 6 when you roll? All right. To find the odds of at least 1 6, what do we find first class?
But not
Odds of no 6s. What are the odds of no 6s? First die? 5 6. Next die.
5 to 6.
Odds of no 6s? 25 to 36.
that's
So
only
therefore, odds of at least 1 must be
11
11
to 36.
to 36. The odds of at least 1 6, 11 to 36.
I was thinking there was 3 dice for a minute. So
No,
that's what I was-
two white dice.
I know.
You can always do that to find at least.
Anytime it's at least 1. Now, if you wanted at least 2, now we have to go back to that tree diagram thing. It's just the way it is. Okay, so, but you can find at least 1 without having to do tree diagrams. Because you just find the probability of nothing and subtract from 1.
You have to use tree diagrams on the quiz.
No. No.
Okay, because...
No, everything we're going to do on quizzes and tests can be done without the tree diagram.
Yeah.
All right, well, without further ado then, go and clear your desk except for a clean sheet of paper and a pencil. Clean sheet of paper and a pencil. Everything else will.
I thought it wouldn't have a quiz on Monday.
Oh, well, I do it every now and then, just to keep you honest. All right, clear your desk except for a sheet of paper and a pencil, everything else away. When you get your quiz, put your first and last name in the name spot and today's date in the date spot. Today is 2/8/21. 2/8/21. February the 8th, 2021. Today's date. And let's take a look at the quiz together. On the front side of the paper, numbers 1 through 7, write the correct answer in the blank. And then for numbers 8 through 10, answering those questions, again, as reduced ratios like usual, based on that information. Then on the back side of the quiz, numbers 11 through 14, just answer each question. Be sure to show your work for these. Notice that number 13 and number 14 are connected. All right, you may begin.